Hello! In this video, we're exploring 5 nifty techniques to supercharge BigQuery's performance while keeping costs low. Who doesn't like more performance at a lower cost? We're in a new project today, and I'll navigate us to the BigQuery SQL workspace, where we'll set up a new dataset. To bring tables into our dataset, we'll import our CSV files from a Google Cloud bucket, giving us better traceability compared to our direct file uploads from our local laptop. Both of these CSV files, alongside the Python script that created them, will be included in the video description. Now, let's dive into importing with BigQuery. Our newly ingested data is looking sharp. We've created 80,000 customers in a table that now sits at 4 megabytes. We'll replicate this import method for our orders. Our first tip is also the simplest: avoid processing more columns than needed. For example, looking at our orders, imagine that we only need the product and quantity columns. By selecting only those columns that we need, we'll be having the 15 megabytes of query processing, which can significantly improve both query time and cost. Seeing wildcards in your SQL queries is a red flag. Only include what you truly need. Tip 2. Exploit the power of the approximate functions provided by BigQuery. Say we're curious about the most commonly ordered product. We can harness the approx_top_count function to reveal this information. This is faster and cheaper than a precisely calculated count, but is still accurate to about 1 percentage point. If you want to see more of these approximate functions, check out the linked documentation. Our third secret is materialized views, which are like a best of both worlds between tables and views. After creation, you have a live, query-ready table, but unlike traditional table creation, the materialized view will be automatically and immediately refreshed if the base table data changes. Big performance boosts can be realized for common join and processing patterns, and the processing cost reductions often outweigh the small increases to storage costs. For tip 4, meet the BI engine. This in-memory cache can bolster both performance and cost effectiveness for BigQuery queries. Just create a reservation, define your capacity, and select the deployment region. For example, if our dataset resides in the multi-region US location, we should match that in our BI engine configuration. This fast, in-memory cache can massively boost performance for use cases like exploratory analysis and BI tools. Further, we don't need to make any changes to our queries or clients, whether in a BI tool, Google Workspace Connected Sheet, or SQL Workspace. The BI engine will be used auto-magically. The cost impact can be challenging to calculate and could be positive or negative. Our final tip focuses on the visibility provided by BigQuery's diverse interfaces. For example, the monitoring suite displays a collection of handy charts, perfect for interpreting your BigQuery usage. We also have more contextual visualizations in pages like capacity management, execution details, and execution graph. As a bonus tip, note that BigQuery partitioning and clustering for tables can help optimize your queries by not scanning unnecessary data and ensuring your filtering and aggregations are logically grouped together in the underlying data. This idea can be visualized in the documentation, where we see clustering for the second table by country, followed by partitioning by date in the third set of tables. In this third configuration, if we were querying data from August 6th, we would only need to scan and process a single partition of data, ignoring all the others. Similarly, in the second configuration, if we were to include a where clause for the country of Japan, we would be able to run that query faster since those records are grouped together. We'll provide a link to a video that explains clustering and partitioning in greater detail in the video description. We'll keep an eye on the comment section for any questions and want to thank you for watching. Please enjoy responsibly.